log of x plus square root of x square plus a square, then prove that x square plus a square d square y upon dx square plus x dy upon dx is equal to 0. Differentiate with respect to x. What we get? Derivative of y dy upon dx. Derivative of log of x 1 upon x. Now derivative of this term, derivative of x is 1. Derivative of square root of x 1 upon 2 square root of x. Instead of x, here we have x square plus a square. Derivative of x square 2x, a square is 0. 2 will get cancelled. Take the LCM here. Square root of x square plus a square plus x 1 upon x plus square root of x square plus a square. This term will get cancelled. So here we have left with 1 upon square root of x square plus a square. This is the value of dy upon dx. Clear? In the next step, squaring both sides, dy upon dx square 1 upon x square plus a square. X square plus a square dy upon dx whole square is equals to 1. Now again differentiate with respect to x. What we get? First function as it is, derivative of second 2 dy upon dx, then derivative of dy upon dx, clear, plus second function as it is, derivative of x square is 2x, a square is 0, here we have constant term, so derivative of that will be 0. So here we have left with, taking 2 common, 2 will cancel, so x square plus a square d square y upon dx square plus x. We have taken 2 dy upon dx common here. Clear? 2 dy upon dx common here. So here we have left with this term. 2 dy upon dx common, x square plus a square, second order derivative. 2 common, here we have left with x. 1 dy upon dx is common. So here dy upon dx. When this term goes on right hand side, 0 upon something is 0. So we have left with x square plus a square d square y upon dx square plus x dy upon dx equals to 0. Note it down. Now the next one is, if y is equals to sine inverse of x, then show that 1 minus x square d square y upon dx square minus x dy upon dx is equal to 0. Differentiate with respect to x. dy upon dx, derivative of sine inverse x, 1 upon square root of 1 minus x square. Now squaring both sides, dy upon dx square 1 upon 1 minus x square. We can write it as this. Now differentiate with respect to x. Differentiate with respect to x, u into v rule. U, derivative of v, 2 dy upon dx, derivative of dy upon dx is second order derivative, plus dy upon dx whole square as it is, derivative of 1 is 0, minus x square is minus 2x, derivative of 1 is 0. Take 2 dy common. Here we have left with 1 minus x square. D square y upon dx square minus 2 is common. 1 dy upon dx is common. So 0 upon something is 0. So here we have left with 1 minus x square d square y upon dx square minus x dy upon dx equal to 0. This is what we want to prove. Next one is, if e power y into x plus 1 is equals to 1, prove that d square y upon dx square is equals to dy upon dx whole square. dy upon dx whole square. We can write this term as 1 upon x plus 1. Now taking log on both sides, by taking log on both sides, what we get? Log of e power y. Log and exponential will get cancelled. Log of 1 upon x plus 1. Y log of e. Log of e has value 1. Log of a upon log of b. Log a minus log b. Log 1 has value 0. And log e has value 1. Now differentiate with respect to x. Derivative of y is dy upon dx. Log is 1 upon x. Derivative of x plus 1. Derivative of x is 1 and 1 is 0. Now again differentiate with respect to x. What we get? D square y upon dx square minus x plus 1 whole square u dash minus u into v dash. So we are left with d square y upon dx square is equals to minus minus plus 1 upon x plus 1 whole square. We can write it as minus 1 upon x plus 1 whole square. Minus 1 upon x plus 1 is the value of dy upon dx whole square. Use 1. So this is what we want to prove. D square y upon dx square is equals to dy upon dx whole square. Now the next one. Write down the statement. If y is equals to x plus square root of x square plus 1 power m, then show that x square plus 1 y2 plus x y1 minus m square y is equal to 0. Differentiate with respect to x. Dy upon dx, let it be x, x power m, x power m minus 1. Now derivative of this term, derivative of x, derivative of square root of x, 1 upon 2 square root of x. X is this term, so derivative of x square 2x and 1 is 0. 2 will get cancelled here, take the LCM. Square root of x square plus 1 plus x. This is the same term, m minus 1, and this term has power 1. Since base is same, so and in multiplication sign, so the powers will add it. M into x plus square root of x square plus 1 into power m. This is the value of y, so we can write it as my upon square root of x square plus 1. Let this equation as 1 by using 1. Clear? Dy upon dx is equals to my into this, squaring both sides, dy upon dx whole square, m square y square upon x square plus 1. Let this as y, x square plus 1 dy upon dx. Let dy upon dx as y1. y1 square is equals to m square y square. Now again differentiate with respect to x. U into v rule. First function derivative of second 2y1 by 2 plus second function as it is derivative of x square is 2x, 1 is 0 is equals to m square derivative of y square 2y dy upon dx y1. So we can write it as 2y1 common from left hand side, x square plus 1 by 2 plus x y1 2y y1 m square. 2y1 will get cancelled from here. So we can write it as x square plus 1 d square y upon dx square plus x dy upon dx minus m square y equals to 0. Note it down. Now the next one. If y is equals to sine inverse x upon square root of 1 minus x square, then show that 1 minus x square d square y upon dx square minus 3x dy upon dx minus y is equal to 0. We can write this term as this. Now differentiate with respect to x. First function derivative of second plus second derivative of square root of x 1 upon 2 square root of x. Now derivative of 1 is 0 minus x square is minus 2x. Derivative of sine inverse x. Here 2 will get cancelled. Multiply this term here, we get 1 minus x square dy upon dx minus xy into upon. So this term will get cancelled here. So we have left with 1 minus x square dy upon dx minus xy is equal to 1. Now again differentiate with respect to x. What we get here? First function derivative of second plus second as it is derivative of first minus first derivative of second plus second derivative of first and derivative of 1 is 0. So we get 1 minus x square d square y upon dx square minus 2x dy upon dx minus x dy upon dx minus y equals to 0. So 1 minus x square d square y upon dx square minus 2x and minus x minus 3x dy upon dx minus y equal to 0. Now the next one is if x is equals to tan of 1 upon a log of y, then prove that 1 plus x square d square y upon dx square plus 2x minus a dy upon dx is equal to 0. We can write this term as when tan goes on left hand side, tan inverse x 1 upon a log of y. A tan inverse x is equals to log of y. Let this equation as 1. Now differentiate with respect to x. Derivative a is constant, derivative of tan inverse x 1 upon 1 plus x square. Log y is 1 upon y dy upon dx. So what we get, dy upon dx is equals to ay upon 1 plus x square is equals to dy upon dx, or we can write it as 1 plus x square dy upon dx is equals to ay. Now again differentiate with respect to x. First function, derivative of second plus second as it is, derivative of 1 is 0, x square is 2x. A derivative of y is dy upon dx. So what we get, 1 plus x square d square y upon dx square. This a goes on left hand side, so sign will change. 2x minus a dy upon dx. Next is, if y is equals to x power x, then prove that d square y upon dx square minus d square y upon dx square minus 1 upon y dy upon dx whole square minus y upon x equals to 0. Here variable, power variable is there, so first taking log on both sides. What we get, log of y, log of x power m, m log of x. Now differentiate both sides. So what we get, differentiate with respect to x, 1 upon y dy upon dx, first function derivative of second plus second derivative of x is 1. So what we get, dy upon dx is equals to y into 1 plus log of x. Now again differentiate with respect to x. d square y upon dx square, first function as it is, derivative of 1 is 0, log x is 1 upon x, plus second as it is, derivative of y is dy upon dx. So what we get, d square y upon dx square, dy upon dx is this term is equals to y upon x. Here multiply and divide by y. So what we get, d square y upon dx square is equals to y upon x, y 1 plus log x. This is value of dy upon dx into dy upon dx, use 1 here. So what we get, d square y upon dx square minus 1 upon y dy upon dx whole square minus y upon x is equal to 0. Now the next one, of a and b. इंडिपेंडेंट ऑफ ए एंड बी मीन्स इसकी जो वैल्यू हमारे पास आए उसमें ए और बी टर्म नहीं होनी चाहिए. सो वी हैव x minus a square plus y minus b square is equals to c square. Now differentiate with respect to x. What we get? 2 times x minus a, 2 times y minus b. Derivative of y is dy upon dx. b is constant, so its derivative is 0. Derivative of c square is 0. Take 2 common, so it will get cancelled. 2 will get cancelled. We have left with x minus a plus y minus